Autumn. The sun is setting rapidly. The sky is moving at the same pace it always does, a 24-hour day. And yet, things seem to hang up there quite a bit. And this will continue until late in December when we have the winter solstice. So things are getting a bit lazy overhead, and I'm getting to sleep earlier at night, except I now have to deal with the Saturn issue. Now, what I've done here is I've removed the Optilong filter. So I'm going to have to be up till about 11:30 to 12 o'clock tonight when Saturn should be approaching culmination, so we can see if we get better resolution without a deep sky filter than we got with it. Because I'm sure our Saturn views should be sharper than the last couple of ones I did. Of course, we're seeing right now the ring nebula Messier 57. But we're seeing it in a 1-second exposure, and I'm using the ASI image right now because I'm trying to make sure the focus of all the stars is sharp. Well, let's push this up to 240x. The stars look good. Even though we've only got a 1-second exposure, we're not really actually hinting at the central star, but I can tell you this one is magnitude 13.1. So even with a 1-second exposure, we're probably getting down to about magnitude 14.5. These real fainty stars we're seeing on the screen. All right, tonight's going to be about adventitious studies because I want to start at the NGC6400 series. Ooh, it looks like that central 15th magnitude star may be there. I want to start with 6400, and I want to stay in the sky's middle third, basically 15 to almost 45 degrees overhead. However, early on, we're not going to get that far north because the roof tri facing to the west is going to block our views. But let's go ahead and get started. We'll put about 20 minutes of imaging time in and do select studies and try to get the best views we can. All right, let's give it a shot. We're going to go over to ASI stacking image, or ASI live stacking now. Okay, first thing I want to point out is now in ASI image, we were actually getting images across the field to right about here. The snipping tool is showing. So what I'm going to do, you can see the central star easily now. Anyway, what I'm about to do is to go ahead and stop this version of the snipping tool, and I am about to go ahead and resize the screen because it cannot be done on the fly. So we're about 3 minutes and 10 seconds in. Let's switch it over. Resize the snipping tool. I'm going to use default settings for the night, and I'll probably just use Movie Maker to change the screen brightness as we move along. Let's take a look at how those stars look. Not too bloated, a little bit fuzzy. I may readjust the focus again, which of course means I have to go back over to ASI Live. Of course, I'll go ahead and wait a little bit on that. But we are seeing M57's 15.1 magnitude central star, which you can possibly get a view through a 12-inch scope if you're averted and you're using some kind of a planetary nebula filter. But let's go on from here and go to NGC 6400s and see what we can pick up there. Okay, I've switched over a 10-second exposure. I only use the 5-second exposures when I have to run through an NGC series. For instance, the last one I did was 1 to 49 with some exclusions due to being either too far south or too far north. What we're looking at here is NGC 6408, Galaxy in Hercules, which has plenty of galaxies in it, by the way. It's magnitude 12.7, 1.6 by 1.4 arc in a spiral with a bar. So look at some elongation in that central brightened region. 181 million light years distant puts it at about 70,000 light years in diameter. It's a right ascension 17 hours, 38 minutes, 47 seconds with a declination of plus 18 degrees, 52 minutes, 40 seconds. This one looks like it has an annulus quite bright at 60x. I'm pushing it up now. I don't like the stars. I may go back soon and refocus, and then we'll go have a look at this one again. But it certainly seems as though the spiral arms are probably wrapping around this sweetie. So let me go ahead and reset focus now. The temperatures have adjusted a little bit. Okay, we're back at NGC6400-6500. We're going to do a bit of our zoomage. We'll go up to 150x. Not too bad, but I don't know that there's been much of an improvement. Maybe it's the sky conditions. We'll push it up to full resolution, which is 240x. Clearly, we're getting a sense of the annulus with the spiral arms wrapped around this galaxy. And we'll go to highest light collecting ability of e-zoom of 100%, which is 300x. There is our view. Now, I will play with the histogram right slider bar a little bit to darken up the screen. Like I said, I was going to probably end up playing with this. I think I'm just going to go ahead and use Microsoft's Movie Maker to adjust it here. But that's a very nice face-on view of Galaxy NGC6400-6500. Here we be seeing an obvious open cluster, a globular cluster, relatively faint, magnitude 10.9, showing some stars. This is a 3.2 arc-minute size globular cluster in Ophiuchus. Stars, the brightest stars are magnitude 15.2. They are definitely showing as points of light rather than faint blotches such as that. So we can go a little deeper at 10 seconds. It's a class 9, which means fairly diffuse, 65,000 light years distant, which accounts for its size. At right ascension, 17 hours, 44 minutes, 54 seconds. I went south for this one because it's a globular plus, further south. It's at +3 degrees, 10 minutes, and 11 seconds. We're not getting a bad view. I can do some zoomage on it. We'll just go up to our 150x setting right there. The stars are looking pretty good, and we'll call it a globular cluster. Okay, one of the things we may want to explore this evening is aspect ratio. The last galaxy we looked at was very face-on, very circular. This one is a 3-to-1 aspect ratio, so suboblate. NGC6430, Galaxy and Hercules, magnitude 13.8, 1.9 by 0.6 arc minutes. Spiral with a lowercase ab, so twice removed from lenticular, 136 million light years distant, probably 70,000 light years in diameter. Right ascension 1745-14 with a declination of +18 degrees, 8 minutes and 19 seconds. And unlike our last globular cluster, it is within the sky's middle third, although it is western. Okay, I'm lured to go deep south because I wanted to check out what the sky was like. At -16 degrees, 28 minutes, 44 seconds, we're getting lots of stars, and that's because we're looking towards the center of the Milky Way galaxy. The other reason I wanted to go here was for a planetary nebula, NGC 6439, magnitude 13, 6 by 5 arc seconds in size, so indistinguishable from a star. But we are going to zoom in. We're at right ascension 1748-19 with a declination of -16 degrees, 28 minutes, 44 seconds. Now, I've noticed we've tended to see things further up in the screen. I don't know why, because I did synchronize the scope. But if there's anything that looks like a planetary nebula in this image, it eludes me. And one of the reasons we're not using any kind of nebula filter. So anyway, we are getting deep south. The sky looks very luminous. And however, we are seeing stars, unlike the other night when I was going to the south and the east, and we were hardly seeing anything. Well, it looks like I've got to resynchronize the screen, but what we're seeing here is another deep south study. You can tell that from the luminosity of the background sky. This is a globular cluster that always got my attention. NGC 6440 in Sagittarius, magnitude 9.3, 1.7 arc minutes in size, so very small. Magnitude 16.7 stars. Highly condensed, reasonably condensed. It's a class 5. 26,000 light years distant, so quite small actually, because that's the same distance as the Great Hercules cluster, which is at least not quite 10 times larger. Let me look at that again. Yeah, at least 10 times larger as NGC6440 is. What I'm going to do is zoom in. As I zoom in, what we want to do is we want to see if we are actually resolving cluster stars, and I do believe we are. Those are magnitude 16.7. They still look like stars. They're not just tiny faded points. My feeling is this scope operating at 10 inches should at least show stars down to magnitude 18. Unless there's something like a planetary nebula, I am going to pretty much stay in the sky's middle third. I can always be lured away, however, by something of interesting and note, because after all, we are adventuring in the night sky on the first day of fall. All right, speaking of planetary nebula, here's one for us, and of course you can tell it's deep south. It's in Sagittarius, magnitude 13, 35 by 30 arc minutes. Nice size. It's got a magnitude 19 central star. That would be an interesting thing to pluck out of the center of this planetary. Does appear to be something right there, but it's a bit offset. 4,500 light years distant. Right ascension 1749.15 and a declination of minus 20 degrees 36 seconds. There is our view at 240x. Looks kind of like a lazy or lying down 3, doesn't it? All right, there is a galaxy right about there in the screen. Let's zoom in, see if it makes sense. What we're looking at here is NGC6452 and further north in Hercules. Magnitude 15.5, 0.6 by 0.6 arc minute spiral with peculiarities. And that usually means some kind of distortion in the normal pattern of what you expect to see in galactic structures. 396 million light years distant, puts it about 80,000 light years in diameter. Right ascension 17 hours, 47 and 58 seconds. Declination plus 20 degrees, 50 minutes and 13 seconds. So the morphology of this galaxy is supposed to be peculiar in some way. It does look a little bit offset. Now, I know when we look to the east, what we get is we get a north here, a south here, an east and a west. I'm going to have to check on this using Steve Gottlieb's references to probably these two stars here to validate tomorrow, because we are looking west at this point. What we should be looking for here is a neighboring galaxy to the last one. This is NGC 6460, magnitude 13.1. And the scope did move a little bit, so this may be our study. 1.9 by 1.1 arc minutes, but it's a class spiral C, and that has a rather bright core to it. Right ascension 1749.30 and a declination of plus 20 degrees 45 minutes 48 seconds. We'll have to compare the two images. There is something I want to talk about here as we look at our 150x view. Oh yes, this is really nice, because this right here is probably an elliptical galaxy or possibly a lenticular face-on. This, however, is a class S spiral C. Now, the difference between an elliptical and a spiral C or a lenticular, if this is face-on, is that there's a couple of major differences. One has to do with their morphology. Lenticular galaxies do look like lenses, and they're bright to the center and they fade off in every direction in a relatively even way. That's because they've converted most of their cold dark matter, not all of it, over to stellar material, and it's happened a while ago. So the brightest stars in the galaxy are now like sun-like stars, about a magnitude fainter than a very, very high star birth galaxy, might have in its original phase, which will have a lot of supermassive stars. Whereas a class C spiral has more stars that are more massive that are putting out ultraviolet light, and the delta between the light that you see here on the screen and the light that's the visual light and the ultraviolet typically is about 0.5 to 0.6 magnitudes difference. So more of the hot, high mass, bright stars in a class C than in a lenticular or an elliptical. And the more of the sun-like stars in an elliptical or a class lenticular spiral than in a class C. Nice little study there in two galaxies. Here we're seeing another galaxy in Hercules, NGC6400-6500, magnitude 12.5. When you get to magnitude sub 12th and 13th magnitude galaxies, you tend to find them everywhere. They were the galaxies that could be picked out with William Herschel's telescope, which was the equivalent of a 13-inch of today, speculum mirror. The fainter ones were ended up taking like the Leviathan and other scopes, the Lord Rosse scope, which more like a 20 to 25-inch telescope or a 40-inch telescope of today. The Leviathan, by the way, was 17-inch speculum mirror. But the reason I called up 6468 is because I wanted to talk about it being a class spiral with peculiarities. That's the morphological definition that has been assigned to this tilted spiral galaxy. Now, the peculiarities, oftentimes it has to do with one direction or the other in the spiral being brighter or fainter than the other. Sometimes it has to do with the distortion in the stellar field, usually induced gravitationally by a neighboring galaxy. Now, I'm not seeing anything in particular that's peculiar about this galaxy, and perhaps it takes a much larger scope at higher magnifications to do so. I would recommend looking at theskylive.com and looking up NGC6468 and see what it looks like through what is called a digitized sky survey photograph that has been converted to digital format. So those give very nice views through a 48-inch Schmidt telescope, typically run between 20 and 60 minutes exposure time. Now, remember, we're only operating at about 10 seconds exposure, so CCD images are much more sensitive than photographic film was in the 1940s and 50s. Pretty decent view. Okay, here we have NGC 6482, probably the brightest galaxy we've seen so far. It's magnitude 11.4, 2.1 by 1.8 arc minutes. Kind of small for an 11.4 magnitude galaxy. Typically, magnitude 12 galaxies are in this range of apparent size. This one's rather compact, and there may be a reason why. Because it's an E3, and it also has peculiarities, which is great because we can see the peculiarity associated with this galaxy. Something is happening here in this part of the galaxy. There also appears to be, this is probably the core, this is probably just a line of sight star, but there does tend to be a little bit of a distortion right here because the nebulosity projects out further than it does on this other side. All right, we're seeing here is a very small 11.9 magnitude, 1.9 by 1.7 arc minute sized elliptical galaxy. One thing about elliptical galaxies is they tend to compress a lot. They look pretty much like very large globular clusters. They've got lots of star formation, very little cold dark matter yet left to turn into stars. This one is 1.9 by 1.7 arc minutes, 344 million light years distant. Now, when I talk about very small, some of them get to be larger than Messier 31, but those are exceptional. This one's probably somewhere around 180,000 light years in diameter, so fairly impressive. It's been swallowing up a lot of its neighbors, one of which may be right here and could be line of sight or it could be proximal in space. That's something to be looked up on your own initiative. Okay, this will be our last adventitious study of the evening. There's a pair of galaxies here and probably quite a bit more. Astute observers of some of this imaging will notice that there are often other galaxies in the same field of view. Some of them are quite vague. For instance, I was looking at the Ring Nebula from an image, and we'll probably see if we can turn that up as our exit study. And there were a couple of galaxies neighboring the Ring Nebula, and we'll see if we can center it up as our Carpe Noctem view. However, this one is NGC6500, a galaxy in Hercules, magnitude 12.1, 2.2 by 1.6 arc minutes. Now, this one looks kind of like it's either lenticular or elliptical. This one is probably our galaxy because it's magnitude 12.1. It's a spiral with a lowercase ab, 1.5 times removed from lenticular class. 138 million light years distant, puts it about 70,000 to 80,000 light years in diameter. Right ascension 1755.59 with a declination of plus 18 degrees 20 minutes and 18 seconds. Let's go see if we can turn up, because it doesn't look too far progressed. Messier 57, we'll have a look at various exposure times and we'll see if we can pick out the IC galaxy that it's in the field along with another. Okay, the experiment I'm going to do right now, and I doubt we're going to see those faint galaxies in the background, is I'm going to play with the histogram. And I am going to break, instead of changing the exposure time, I'm going to change the view. I'm going to use the right slider primarily for this, although I may experiment. Here's Messier 57, here's that 13.1 magnitude star, and clearly, right in the center of the field of view, is that 15th magnitude central star that should be just visible if it weren't for the luminosity at the core of the Ring Nebula Planetary through a 12-inch scope. Now let's go ahead and this is a very nice view. To get a view like this, I would ordinarily have to reduce the exposure time to 2 seconds. But why not just play with the right histogram slider setting instead? Now I'm going to run it up, and you can see it's getting brighter and brighter. It's almost as if we are actually increasing the exposure time, but there's another factor here. The stars look pristine against a perfectly black background sky. So I probably should spend more time at longer exposure times and play with the histogram sliders to get those really picturesque views that we all like to see in publications. So I'm sliding the histogram slider up to a point where the last bit of light appears to drop down towards the pointer, because at a certain point it just starts going up and to the left, and that's where I've got the slider now. Now I do remember, I believe, from looking for this background galaxy that they are somewhere in this region up here. So here we go. We're going to move the slider over. We're going to brighten the background sky, increasing the sensitivity of the imager and its display. Meanwhile, we are going to lose, well, the Ring Nebula is looking pretty good. All right, I can see one of the galaxies now. The brighter one is, where do you think it is? Right there. But I do believe there's an even fainter one that we might be able to turn up. And I do believe this is an IC, and I have, I think, labeled it in a past video. So here we go. Now I'm really brightening up the background sky a little bit, teasing out more fainter and fainter nebulosities. Okay, now I've increased the background sky completely by using the left slider because I want to reveal that faint galaxy. And the way to do that is the left slider, this slider here. Now, as I recall, If you follow these set of stars down, you're going to find the galaxy, an even fainter version of a galaxy in there. But we're probably going to want to have to push it up to 150x. So have a look down in this region over here and see if you can't pick out a fainter galaxy. So that's our 150x view, which is about as good as it gets. Notice this galaxy over here looks like it's a two-armed spiral, which would mean it would have a capital B, and it looks like the core is a bar. So it's going to be a class S capital B because it's got two arms, and it's hard to tell whether or not it would be, I would say you'd have to look at the delta between the blue violet and the visual light to determine whether it's a SB little a, SB little ab, or an SB ABC. However, due to the brightness of the core, I don't think it's a C, although we've seen a number of Cs that really have fairly bright cores. So it could be anywhere in that range from half removed, once removed, 1.5 times removed, 2 times removed, or 2.5 times removed from the lenticular class. Both its morphology and the kind of light it puts out tells us much about the age and maturity of the galaxy. So with that, let's see, with multiple stacks, are we seeing another galaxy in this region? Well, I recommend you go to theskylive.com and look up the NGC value of Messier 57 and see if you can make out galaxies that may be in its region. And with that, I am going to say carpe noctem.